3 minutes.
Okay. Well, hello, everyone. Sorry. Yeah, we're a bunch of water guys at Active Membrane trying to solve a global existential crisis, which is the access to fresh water. It's an interesting statistics. About less than a percent of what we have considered as water on the surface of the earth is fresh water. And it's not evenly distributed, and it's not evenly used. The countries that have it use it more than the countries that don't have it. And we're running out of it. So what do we have to do? Is we have to go and make fresh water out of the other 99% that is available. Today we do that through a process that is called desalination, removing salt from water. At the heart of every desalination plant, there is something that is called reverse osmosis membranes. These are the heart of that, and they separate the salt and the other impurities from the water. But because these waters are heavily contaminated with several classes of contaminants, these membranes clog. If they're not inhibited, they clog quite quickly, and they lose their performance. That's why we have to do a couple of things. We have to limit the freshwater recovery, and then we have to put extensive pretreatment behind it. That means that we generate a concentrated waste that now has to be disposed. And it makes a desalination plant a big, ugly thing, very expensive, environmentally questionable, and probably even not sustainable. So desalination today, because of all these things, is a last resort technology with a very limited market, and it's ripe for disruption. At Active Membrane, we're trying to change that. We want to make a membrane, a reverse osmosis and nanofiltration membrane that can inhibit scaling and fouling and clogging without having to resort to additional pretreatment. It operates at a higher recovery and significantly reduces the capital and operating cost of existing and new desalination plants. More importantly, it's a drop-in replacement for an existing membrane. So by doing so, by giving the power to the membrane to do its own fouling control and the scaling control, we want to make sure that desalination is cost-effective and sustainable, not a last resort. We want to make sure that everybody, from big users all the way to households, can use it, and we want to enable an existential human right, which is access to fresh water. Been a busy year for us. A lot of awards, and a lot of awards and grants, very high, prestigious ones from different entities. And we've also been raising our seed round for $5 million. $2.5 million is secured, and we're looking to fill up the other 2.5. Thank you.
Thank you so much. Okay, who has the first question? Yes.
I'll go first. What is your initial form factor, and who's your customer?
Spiral wound form factor, which is a standard form factor for desalination membranes. Goes from anywhere from 2.5 inches to 14 inches long, all the way up to 80-40, which are the different form factors within a spiral wound. Our initial and beachhead markets, we're going after plants that are struggling from process of scaling and fouling. These are nominally groundwater brackish plants inland. We're also looking into seawater desalination. The value proposition we have for seawater desalination is biofouling mitigation, as well as enhanced boron rejection. Boron is a very important factor, and these are our initial beachhead markets and clients that we're going to go after.
To clarify, you're selling into the exact same desalination plants that are currently using less the passive membranes, and it's the same size. It can literally just drop in and
Absolutely.
replace.
It's a drop-in replacement.
And in terms of ROI of using yours versus using their de facto solution, help us understand the value.
We are planning to sell it at the same cost level as the current membranes. Our COGS are a little bit higher because we're adding a little bit to the design of current spiral wound membrane, but not high enough to not enable us to sell it at the current. Obviously, if there are niche applications, we can sell it more, we'll try, but at the worst case scenario, we can sell it at the same cost level as the other guys.
To kind of layer on to Matt's question, have you looked at the holistic value that you're providing to your end customer here? let's say for the desalination plant, right? Because they have to do more processing, or there's that kind of a lot of kind of ancillary kind of impacts and whatnot. Have you looked at kind of what the total ROI is if they use your process? Versus, it's not so much that you're selling it at the same price as another, but the total value kind of created by you. Maybe it's the decrease of cost per gallon of water, like
Right.
that effectively comes out,
Right.
right? And how that effectively becomes much more equivalent to some other methodology.
Absolutely.
So have you
What
looked
a
at that?
great question. Yeah, there are two things, tangible and intangible. Tangible is obviously the cost of capital and operating. For existing plants, what we can do is we can reduce the reliance on the current pretreatment. For example, we are going to be doing a pilot next month at a plant that has a lot of resin exchange unit operations. These are consumables, very expensive to run. They have to be regenerated all the time. We either can completely bypass them, or we can bypass them at the rate of like 30% or 50% or whatever, reducing the load on them. That gives the clients something in the region of, at minimum, 25% all the way to 40% operational costs. These are tangible costs. In new plants, it means less unit operations, which means better capital for building in new plants. But intangible ones is, I've operated desalination plants for at least half of my career. Making sure that your operators don't have to stress over maintaining several unit operations. It means that your preventive maintenance program is going to be much simpler. It means that your operation is going to be much simpler. You're going to have a lot happier operational staff, and it's going to make sure that if you want to do hands-off operation, like digital, remote, these kind of things, it enables you a lot more because you have less sensors and you have a lot of other stuff that can go wrong.
So just as a suggestion, to make it easier to digest for an investor basis, if you fundamentally quantify, look, it costs $2 a gallon right now for it to actually come out with a clean kind of gallon of water, right? I'm going to make it be able to go down to $1 a gallon.
That's exactly what
right?
it is.
Like, whatever that is.
Actually, so what I'm struggling with, because I don't know how many desalination plants there are and how much they're spending every year on replacing the passive membranes or downtime of the facility, like help us understand how much is currently being spent with the status quo.
Absolutely.
And then how much would they spend with you?
Absolutely. Let's assume a cubic meter, which is a universal desalination unit, right? 1 cubic meter of water through desalination, depending on what desalination plant you're looking for, costs anything between $0.50 per cubic meter all the way up to $2.50, right? Depending on which application it is, we can reduce this by at least 40% all the way up to 70%. That's essentially the gist of it. For operating, meaning existing plants, as well as new plants. More for new plants because we save on unit operations as well.
So you talk about making desalination not the last resort.
Right.
So currently, I love that you're drop-in. It's very important. It does mean that you're going to be being used in established or newer plants. But how do you make the leap from, because you're not actually building the desalination plants, for it to become sort of the basic de rigueur status quo?
Well, you have to look at why desalination is the last resort, right? Because here in California, it takes about 14 years to permit a seawater desalination plant. And at the end of it, it's at best 50-50, right? So the government of California knows that they need desalination. So they've forgotten about the seawater desalination and they're going inland. Why they're doing that? Environmental sustainability, because you have to return this concentrated waste back to the sea. The cost, the footprint. Now we're removing all of these energy barriers, or at least minimizing them. So when an end user goes to permit a desalination plant, instead of having to answer and providing satisfactory answers to 50 questions, now they have to provide satisfactory answers to 5 questions because the energy barriers are removed. Are you going to use all this footprint? No, I'm going to do 50% less. Are you going to put this amount of waste back into the water? No, I'm going to put less, half of it, and so on and so forth. By removing energy barriers, trying to make sure the end user, the adapters, have to struggle with less problems that they already are struggling with desalination plants, making it the last resort.
And how about the upfront CapEx costs of these desalination plants?
So we have looked into that for different scenarios. We believe that we can save at least from 20% all the way up to 40% capital expenditure savings.
On the filters or the total?
Total, because we will be using less unit operations. So there are cascades of unit operations as pretreatment. We're minimizing on those unit operations. So
That'd be
less
huge,
pumps,
but it's
less
hard to believe.
Well, I'll invite you to come to one of our pilots, and then we'll give you a demo.
Sounds great.
How many desalination plants are there globally today?
The number is a lot, but in terms of capacity,
I mean, are we talking about thousands, tens of thousands? Just in
no, we're
terms
talking about hundreds of thousands.
Hundreds of thousands?
Hundreds of thousands. There's 90 million cubic meters a day produced, 90 million cubic meters a day produced worldwide.
Hundreds of thousands of plants?
Just about, if you consider all the small ones all the way to big ones. Desalination plants, what general public knows about desalination plants are things like Carlsbad, which are the big plants.
Yeah.
Well, there are a lot of micro plants in the world.
Yeah.
There's this, beverage company that has a 1,000 gallon a day desalination plant and so on and so forth.
And then in terms of your revenue potential per plant, help us understand, on the Carlsbad plant, we could make X million dollars a year. On a smaller plant, we can make Y.
So again, it depends on the application, but membranes are typically anywhere between 10% of the cost of the plant all the way up to 60-70% of the cost of the plant, depending on how bad that plant is operated, how well it's designed, and so on and so forth. So I'm sorry that I can't give you more specific, but desalination industry, desalination processes is highly dependent on the type of water you're trying to desalinate, right?
20 seconds, but I hear it.
So
I
do
see.
you have a sense for how much these plants spend on filters per year, membranes per year?
So, yeah. So if we're assuming, let's assume on a small plant, 150 gallons a day, right? That plant typically has about 50 to 75 membranes. Let's assume 50 membranes. These membranes are about 600 a pop. That's 50 times 600. It's about $30,000 a year. Now, depending on how well it's operated, it could be replaced every 6 months. It could be replaced every 3 years. So again, there is a range here. It could be anything between like $30,000 a year for such a plant, all the way up to like $5,000, $6,000, all the way down to $5,000, $6,000 a year.
Thank you so much for your presentation. And I think what you're hearing from the questions is maybe you can you have something really interesting, and maybe you can clarify a bit more up front the market opportunity.
No, absolutely.
Yeah.
Thank you.
Great. Thank you.